Alrighty, in this video we're going to talk about hoisting. Now, JavaScript hoisting is, if you're familiar with C#, it is not similar to C# hoisting. It's actually in the specification defined as a little different, and we're going to talk about what it is, what it does, what to watch out for, and again, another source of many junior JavaScript developer interview questions. So, let's get started. We'll comment out example 11, and let's go ahead and move on to example 12. So, example 12. Let's do function example 12a. Console log a, console log end of function, and we're going to invoke it. Example 12a. What do you think the output of this program is going to be? Now think. All right, let's go ahead and hit Control S. Reference error. We crashed. The whole program, the whole function crashed, and execution ended. Now, what is reference error? A reference error happens whenever you try to refer to the value of a variable that isn't found. A is not found because what happens is, again, the JavaScript engine is going to say, hey, you're looking for a variable called A. Well, let's walk up the scope chain. What's the scope chain going to be? Well, the scope chain, first of all, is going to be this function. This function created a scope. Wait, there's no local variable or parameter called A in the scope. Let's walk up. Okay, now we're in the global scope. Is there a variable on the window object named A? No, there isn't. Throw your hands up and just die. So we get a reference error. So a reference error, it tries to use a variable as a value, and it couldn't find it, which is interesting because if I change this a little bit and said a equals 10 and hit Control S, notice how we didn't get a reference error. I can come over here in my console and I can access a globally because it was attached to the global scope. That's because right here is what's referred to as a left-hand reference to a. When you do a left-hand reference to a variable, it means you're trying to stuff something into it. Go away, CC Cleaner. So what's doing is, a left-hand reference to a variable says, I'm trying to put something in this piece of memory. And it behaves differently from a right-hand side reference, which we have right here, where we try to use a value, which is a question. A question is, I want to find the value of this variable. When we try to stuff data into a variable, in a left-hand expression, what it's going to do is it's going to walk up the scope chain, find the first variable called A. If it hits the global scope, then it'll simply attach that new variable to the global scope, right? Now, in a right-hand expression, it does the same thing. It'll walk up the scope chain, but when it doesn't find it on the global scope, then it'll throw an error. So it's a very important distinction to understand the difference between a left-hand and a right-hand. It's kind of confusing, I think, to some people why it's perfectly valid to assign a value to an undefined variable whereas an undeclared variable, because there's a difference between undefined and undeclared, we'll talk about that, but there's a difference between trying to assign a value to an undeclared variable and trying to access the value of an undeclared variable. And we'll be talking about more of that in this video when we discuss hoisting. So that is example 12a. Let's go ahead and comment this out because this example is actually crashing our crashing our runtime. And now let's do example 8b. I don't know where I got the number 8 from. I meant 12. So this is going to be fun. Let's go ahead and start off exactly how we did before. Console log a, console log end of function. Then I'm going to do something silly. I'm going to say var a. And now I'm going to come down here, do example 8b. I'm not going to hit Control S yet. I want you to figure out what the output of this program is going to be. Again, this is another common thing you will see on junior JavaScript developer interview questions. So let's go ahead and hit Control S and check out the output. As you see, there's a stark contrast. These examples are practically identical. The difference is in example 12b, I declare the variable down here. And the output that we get is undefined. So A is now undefined. I mean, I could even... well, we'll talk about that in a second here. There's another example that I want to talk about. But before I do that, before I really describe the behavior of what's going on here, I want to write that example. So let's go ahead and I'll comment this out with block comments so it's easier to read and refer to these both. And I'm going to do function example 12c, and this is going to look very similar. I'm going to do console log a. And then I'm going to do console log end of function. And then I'm going to do something silly here. I'm going to do var a equals 10. All right. Same question. What do you think the output of this example is going to be? Let's go ahead and hit Control S and see what happens. As you see, we get the exact same output. So, what is going on here? Let's go ahead and define hoisting. What is hoisting? Hoisting means that when the JavaScript compiler, when the JavaScript runtime, whatever, sees a var keyword, it figures all that stuff out before it executes the function. Meaning, simply by doing var a, simply by writing that piece of code, simply by declaring a variable, before the function is even executed, that variable is now known, and not only known, but bound to the scope it was declared in. And what's the scope it was declared in? Well, remember, how do you know what scope a variable is declared in? You look at the closest function, and what's the closest function? Example 12c. So the var a gets attached to the example 12c scope before the function is executed, and that is called hoisting. Hoisting, you kind of think about the English definition of the word, you pull something up. So as far as JavaScript is concerned, every single time you make a variable, that var a is going to be put at the top of the function. You can kind of think of it like that. But we see that it's interesting because we don't get that behavior with the assignment. And that's the difference between example 12b and example 12c. We have an assignment here and a declaration. And that's because var a equals 10 is two things. It's actually two things in one. Let me split it out for you. There. So when the JavaScript compiler sees var a equals 10, what it translates it into internally is var a semicolon, end of line, full stop, followed by var equals 10. And these two things are very, very different. One is a variable declaration, and the other one is a variable assignment. A variable assignment gets executed in order, meaning this a equals 10 has not executed by the time this console log a. If I had put console log a right here, you'll notice we get undefined, end of function, and then 10, right? Just the behavior we would expect. But this var a is different because, remember, the JavaScript compiler parses this function body and establishes all of the variables before it executes the function. And what it does is it takes this var a and it moves it right up to the top. Meaning this is what the compiler sees when you write that. So this is what we write. This is what the compiler sees. Var a is at the top, but the assignment is still at the bottom. So hopefully that behavior will make a little bit of sense. It causes a lot of confusion to people. And what's interesting is there's a difference between an undeclared and an undefined variable. An undefined variable in JavaScript is a valid variable that exists in memory. It has been allocated. It is taking up space, but it has no value. It's undefined. No value is ever assigned to it. An undeclared variable is a variable that doesn't live anywhere. No memory was allocated. So this a right here in our first example, maybe I'll to make this more clear, blah, blah, blah. This first example, we have an undeclared variable. It was never declared, no memory was allocated, it was never added to a scope. But here, we have an undefined variable. Memory was allocated for that variable. JavaScript knows about the variable, knows where it lives, it knows what scope it's in, but it has no values. Undeclared and undefined, two completely different things. An undeclared variable will cause an error. An undefined variable will simply print out undefined when you try to console log it. So to sum it up, I'm actually going to rewrite this the way that we saw it as we wrote it. To sum it up, when you write this, always imagine every time you see a var ble equals ble in any function, that gets hoisted up to the top of the function. That function is now declared. It is part of that scope. It's been attached to that scope. Memory has been allocated to that variable. And it can cause confusion. But it doesn't matter. The funny thing is again, the variable will get hoisted up to the closest scope. Meaning if I did something like if false, see, this is going to be kind of funny. If false, I'm getting yelled at by Visual Studio Code because unreachable code detected. What do you think the output of this program is going to be? Do you think it's going to crash? Or do you think we're going to get undefined? Let's find out. Check that out. undefined. Whoops, go away. Undefined. This code never got executed because it's in an if-false statement. Visual Studio Code is even telling me, hey, buddy, you wrote an if statement that'll never execute. But it still gets hoisted up to the closest scope. If I removed it entirely from the code, that's when we're going to get the uncaught reference exception. Now, let's talk about function hoisting. Function hoisting is cool. This actually has practical applications. And furthermore, not only does it have practical applications, it'll demonstrate the difference between the function declarations and function expressions that I was alluding to in the last video. So, yeah, stuff and things. Let's go ahead and get started. Function example 13a. We'll do console log I am function. And then I'm going to call inner. And then I'm going to return. Then I'm going to console log dead code, in quotes, on purpose. And then I'm going to say function inner, console log I am inner. And then I'm going to say example 13a. Let's go ahead and hit Control S. And I should have done the whole, what do you think the output of this program is going to be first, but I kind of hit Control S too quickly. As we see, it works. Now, interesting that this is technically dead code. In fact, Visual Studio is warning me it's dead code. It's unreachable because there's this return statement. So I invoke example 13a. When I do that, this code gets executed, that code gets executed, then we return. Notice that we don't get a crash. In fact, we get the output, I am inner, or I am function followed by I am inner. So we see that functions are hoisted too. All right, so pretty straightforward. You can take all the stuff I talked about variables in the last part of this video and apply it to function declarations. Function declarations are hoisted. In fact, I can prove that by invoking example 13 before it even reached this function example 13. See, it still works, even though I'm invoking this function before it was executed. Functions are hoisted. In fact, this function has been hoisted to the top of this file. Well, I mean, obviously, we just have a bunch of comments about code, so there's not much for it to be hoisted over, but technically it is accessible from anywhere within this file, so that's function hoisting. Now, what's interesting, though, is if we slightly rewrote this. So I'm going to comment this out, and, well, no, I'm going to comment it out with block comments so you can see the indentation properly and compare these two examples. I'm going to do function example 13b, because I am great with names. Console log I am function inner followed by return followed by var inner equals function console log I am inner example 13b. So what do you think the output of this program is going to be? I'll think for a second. Now I'm going to hit Control S. And we're dead. Uncaught type error. Inner is not a function. Well, that's weird. Made it a function right here. Well, this is the difference between function declarations and function expressions. So this is a function expression. Inner was hoisted. This is a function expression, function declaration, and this is a function expression. Let's think about the differences between the two. And let's notice something very subtle about this that I'm not sure you might have caught. Remember when we tried to reference in an earlier example, I think example 12a, we referenced a as a right-hand side value. So we try to get the value for it. And what error did we get? We got a reference exception. A is not defined. But here, we're trying to access inner. We get a different error. Uncaught type error. Inner is not a function. Now, why do you think we're getting a different error in this case versus our previous case where we tried to access that variable? Think about it. What do you think the behavior of this is going to be? Well, it actually comes down to something I've already mentioned in this series, and that is a function expression is two things. A function expression is a variable declaration followed by a function expression. Let's break this code out to how the compiler, how JavaScript sees this code in reality. Var inner semicolon followed by inner equals function. Which means, actually this return statement is actually unnecessary. The code will still crash, by the way, whether I have that return statement or not. I kind of added that return statement in for dramatic effect. Hopefully it was dramatic enough for you guys. So So what's going on here? So the function expression, we're creating a variable and then assigning it to a function. Now, the variable part is just as far as the compiler sees it as far as it's aware. It's nothing more special than a average variable declaration, just like the variables we've been declaring and hoisting in our previous example. So this var inner gets popped up all the way to the top, right? And gets set to undefined. So I can go ahead and say console log, what is inner? Console log inner. What do you think it's going to be? It's going to be undefined. So right here, it's undefined. That's because this declaration was hoisted up to the top. This variable declaration was hoisted up to the top. And it's undefined. And then when I try to invoke it as a function, I don't... Whoops. Go away. I don't get a reference error saying that inner is not defined. I get a type error. And that's because if you try to invoke undefined as a function, JavaScript will kind of pack its bags and go home, because what does that even mean to invoke undefined as a function? Undefined is not a function. Undefined is undefined. So we see, in stark contrast to our function declaration, our function expression is only assigned that functionality, that being a function, when the compiler reaches that code. And I can prove that by removing that return and taking my call to inner and moving it to below the assignment. See, below the assignment it works, above the assignment it doesn't. And that's because when we're up here, var inner is accessible as an undefined variable, as declared but undefined variable, because it gets hoisted, remember? It gets moved up here. And then it's only turned into a function on line 261. So we can only call it as a function after line 261. So that's a trap that you're going to run into when working with function expressions versus function declarations. So it's an inherent difference. And it might become more clear now why I put semicolons at the end of my function expressions, but not on my function declarations. Function declarations are like blocks, like if statements or while loops or switch statements, and you don't put semicolons after those. Whereas function expressions are expressions. They're actual assignments, and you should always put a semicolon after an assignment, because that is an expression, and a semicolon instructs JavaScript that the expression has been terminated. So you might be wondering, let's do another example. I'm not going to write another example. I'm just going to make this back into what it was a second ago. And I'm going to slightly modify this. What do you think the output of this program is going to be? Notice how I'm now using a named function expression right here. Remember this guy that looks a whole lot like a function declaration? Well, remember, is this a function declaration? Say Control S. No, it's not. It is a named function expression, which does not behave... which behaves more like a function expression than it does a function declaration, meaning it's not hoisted. Remember, this name is arbitrary and only accessible from within this block. It does not in any way impact the behavior of this particular example. And that's it. So to recap, let's unhide these so I get some syntax highlighting action here. Let's just do a really, really quick recap. Hoisting is very straightforward, but something you need to be aware of. You need to understand it. So again, to recap, variables, if you try to use a variable as a value and it's not defined, you will get an error. And remember, by simply doing var a, you are defining that variable, and it's accessible from anywhere within that scope or subscopes. Remember that variable assignments are not hoisted, only the variable declaration, so only the var a part is moved to the top. The equals 10 part stays where it is. You can hoist function declarations, or function declarations are always hoisted to their parent scope. Function expressions, however, are not hoisted because this is actually not a function. This is a variable that just happens to be assigned to a function, and there's a difference. And then finally, named function expressions don't change this behavior. And that's it. That's hoisting. Something to keep in the back of your mind, cause of some confusion. I hope I cleared that up, and that's just the behavior of JavaScript. And we'll see you guys in the next video.